Hey everybody, so today I wanted to talk about counterfeit coins, how to avoid them, and what really are the best strategies of detecting physically when you're dealing with a coin in person, how to make sure that the coin you're dealing with is not a fake. So I wrote out a list here of the properties of how how to be sure about what kind of coin you're dealing with. Every coin, I'm going to pick up a silver coin. This is a silver eagle. That's a 2010. And hope y'all can see it with the lighting. Sorry if my lighting ain't too great. But every coin, if you look at this list here, has certain magnetic properties, the weight, the dimensions such as the thickness and diameter. There's a specific gravity to it, which is, I believe, the ratio of the mass to the volume that mass occupies in space. Sound propagation velocity, which is more of a high-tech method, but it's actually not that expensive to get a machine that can check those. And a lot of the professional bullion dealers do that. It's really good for bars. I don't know about coins, but that's because you have to put a gel, I believe it's glycerin, and on the coin, so if you're not comfortable with doing that, you certainly wouldn't want to do that with a rare coin. Some $5,000 Carson City, right? But I would say that on bars, that's not so bad. And then most importantly, I underline this one. I want everybody to get a good look at it. The details of the coin. Most of the counterfeits you run across, they're piss poor in terms of detail. I'm sorry, they are. There are some, and it's only on the really high value coins that have really good details. Where if you look at it long and hard under magnification with a magnifying glass or with a jeweler's loupe even, there are very few of them out there that will pass the scrutiny test. Keep in mind, the first thing a lot of those NGC and PCGS graders, first thing they do, put that sucker under magnification. It's not just, oh, hit it with an XRF scanner or whatever. I didn't put that down there, and I'll get to that in a minute. Actually, never mind. I'll probably get to that in another video. But the first thing a lot of them do is just take a look at it. Okay, what are the details like? Is the hair right on this Morgan dollar? Are all the devices on the obverse correct? Is there anything out of place? Is there is the font wrong on 1889? Is there a little line missing on E pluribus unum? You know, somewhere on the B or the R, one of the little tail lines, or how about on the reverse? Is there an extra feather? Is there, you know, is something missing or something added or something inaccurate? That's basically what it comes down to. Details is probably the best way to detect a coin being fake or not right off the bat. But let's go with this from a scientific angle. Now you can't see this, it's out of view. This is a caliper. So first thing on any coin, I brought that up. This is a scale right here. Come on, come into focus, camera. There we go. First thing you're going to do on any coin to make sure if it's real or not is you're going to take a high quality scale like this, and you're going to find out what that thing weighs. Every coin has a specific weight. If you're buying 1 troy ounce of silver, a troy ounce of silver is 31.1 grams. Now, a silver eagle, there's actually a certain tolerance for how accurate that should be. There's inaccuracies both in the scale and from production, but those accuracies are very, very minute, preferably less than 1%. So 1% of 31.1 grams, I believe, is 0.3 grams. Yes, yeah, I think that math is right. But for our purposes, at 0.3 grams times 10 times 10, yes. But really, I would prefer it be even more accurate than that. Let's see what this thing actually weighs. And actually, hold on. I'm going to take this thing. This is a plastic case. I'm going to tear it, zero it. Now, the case doesn't come in contact with any other parts of it, just the scale itself, because the scale is actually raised slightly, so it doesn't actually touch the rest. So it's accurate, don't worry. 31.29. Okay, let's touch it, make sure that it re-zeros correctly so it's not off. 31.29 grams. Let's change the units to, that's ounces, that's troy ounces. 1.006 troy ounces. That's extremely close. So let's remove this. And just for anybody that might think that the case is interfering with it, put it on here without the case. Very lightly. I don't like metal on metal contact, but it is a bullion coin and it doesn't really matter, but just see, I proved my point. The case cover doesn't interfere with it. Now, I would advise, the reason I used that case in the first place, this is a bullion coin, it doesn't really matter, but if you're dealing with something rare, like an old Morgan dollar, I've got some other silver coins here, a silver half, quarter, another quarter, but it's the standing Liberty design, and I got a silver dime. I also have some various other coins. I've got a gold coin here, this is a $5 Liberty coin. I've got a commemorative Texas half dollar. Yeah, Texas. And I've got some, I got an Eisenhower dollar, clad, and a Jefferson nickel. So the advantage of putting a coin on the plastic is smooth. You don't want metal on metal contact, because if this was metal and this was metal and they abrade each other, you don't want that, because obviously that would scratch the softer of the metals. And what do you think is softer, silver or steel? Steel is, I mean, we make guns out of it. This thing's made out of it, so I'd like to think that I wouldn't want my silver coming directly in contact with the harder metal. Anyway, but if it comes up right on the scale, the next thing we're going to do, I'm just going to keep using this one example coin. My bad. Don't worry, it doesn't really matter. None of these coins are really numismatic value except maybe the Morgan. Next thing we're going to do is take a digital caliper like this and check the diameter and the thickness. So it's going to take a while. I have to do this quite slowly, and actually if I go too fast, it can become inaccurate. So a silver eagle should be 40.6 millimeters in diameter. However, I'm going so far out with this thing, you see how I'm rolling it with my thumb, it could become inaccurate just due to my own errors. You have to go slightly beyond what the actual diameter is, just to make sure that you don't scratch the coin on the caliper, and then touch it to, I'm going to give this as a tip to anybody who collects coins, put it on the soft edge, not the part with the angle to it, because at least with that greater surface area on this part, you're not going to scratch the coin, or you really, it's hard to do it. It's harder to scratch the coin. So then once you got it down and lined up, put this back here. Obviously this is somewhat tedious, takes some time. 40.69 millimeters. It's 1/10 of a millimeter off, approximately. But that could be, like I said, due to my own rolling, and I'll show you what I mean by that in a moment. So let's roll this sucker all the way back down. Now, I believe these are supposed to be 2-something millimeters thick. I can't remember what exactly the thickness is. Hold on just one moment. I'm going to keep rolling this down off camera, but I'm going to go back to Google thickness of silver eagle. Okay, there we go. Silver eagle, come on Google, is supposed to be 2.98, well, 2.98 millimeters thick. So there's 12.5 millimeters. 11, 10, 9, 8, 7, 6. Oh shoot! See how my caliper became inaccurate? That's because of all the rolling. So zeroed. This center bar moves. This center bar that comes out. And so I don't know. I'm not trying to make this brand seem bad, but you got to be really careful about the calipers you get. You got to recheck it, and that's the other thing why this number, very important. I actually tend to reference against that, to be honest. So let's roll this thing out to 2. Let's go to 4. Make sure that, oh yeah, another tip, if you're going to be measuring the edge thickness, the thickness of the rim of the coin, try to make sure that only enough, I'll show you like this, that only enough of the coin comes through to touch that area so that it doesn't touch the sharp point. 2.95, that's very close. Okay. You only want it to touch the larger the surface area is, instead of these little pincer looking parts, the better, because this is much more likely to damage a coin than say this flat edge right here. Much more likely. I'm not saying that this wouldn't, but which one's more likely? This thing looks like it could cut something, right? But what about this? not so likely. Anyway, comes down to 0. And just for any naysayer, they'll do a quick one here. I'm going to check against that physical. Now this is harder to actually measure. You see how it's extremely close to the 40. It does matter that you get an exact measurement, but I do believe it is accurate. I do believe it is real, but for a final test, this is what I was getting at with magnetism. Now, any real silver or gold coin, they're not magnetic. Silver has what's called diamagnetic properties, which means if you put this coin on the edge of your finger, hold it like that to where it's slightly wobbly. You don't want it stable like that. You want it to be a little bit wobbly. Take a magnet like this. It's a very powerful industrial grade magnet. I took it off of a tool. And you want it to be free enough to work and wobble. And you're going to kind of wave this thing over it, but not so close that you actually touch the coin. It's actually very hard to do that. And you don't want to do it perpendicular to the surface. You want to do it, to the axis that your finger creates. You don't want it to be parallel. You want it to be perpendicular, so that whatever direction it would wobble in, you make the magnet go in that direction. Because if you're doing it like this, well, what's it going to make wobble? Nothing. You want it to do that, travel in that direction, because it's creating these magnetic fields within the silver. I can't explain the physics of it in this video, but basically it creates a contrast of magnetic fields. So you'll be able to feel this in your hand if you go faster. You want it to oscillate faster. You want that contrast. And you should be able to feel the coin wobble. If the coin were to stick to the magnet, then that means it's made of a base metal and not silver, and that means it's counterfeit. If it were to not wobble at all, this is actually harder to measure because you might have the magnet too far away from the coin or not powerful enough. You can't use a refrigerator magnet. This is an industrial grade magnet. Here's the caliper. It just picked up the caliper. The caliper ain't that light. It's fairly light, but it probably weighs a few ounces. I'll put it on that scale, find out what it weighs, but not right now. Final test. So I brought up magnetism for this purpose. This is a Sigma Metalytics. This is an $800 machine, although they have been coming down just a little bit. You're going to take this coin. Also, just before I go any further, I'll tell you how to work this machine real quick, and I've also got the manufacturer's guide here on the sensor specifics depending on the dimensions of a coin. But I actually made a little chart for everybody. The details of the coin. Okay, so the Sigma Metalytics sensor chart for different coins. The main sensor, which is what this is, you're going to use for silver eagle, silver dollars, and you can use it on half dollars and quarters made of silver. However, you can also use the large sensor, which is what this is. Give me a second. This is the wand. You plug it into the side. It's okay, it's just bullion. Ooh, I took 1 cent out of the value. Probably not. This isn't even, it didn't hit a metal surface. It would have been much worse if it fell in a pile of nails. But you plug it into that, and then that light comes on. And then you can use the sensor select button to change sensors. And you can use this large wand on half dollars and quarter dollars as well. And then the small sensor you use for dimes. However, one key trick, one thing to keep in mind. Let me pull out a dime, for example. This dime has a diameter of, oh gosh, I don't know, 1.25 millimeters. This one specifically, I measured it earlier, although most should have 3.5. If it's below, if it's a worn coin, if it's been worn down, all the details are gone, kind of like this Standing Liberty quarter where there's no date and all the details are pretty crummy. You can't actually see anything on Lady Liberty. You just see somebody standing there, but hell, you can't even really see the trust, and in God we trust. Almost, I mean, in person, yeah, even in person it's hard to see. In God, that you can see, that's visible, but anyway. So, forgive me for dropping the silver eagle, but errors are the ways of humanity. So, remove sample, run cal, start. I'm going to bring the camera to zoom. Come on, zoom in. This camera's slow as hell, for the record. Okay, so you can see down here it says remove sample. Run. Okay, I'm going to remove everything from the board. So it's automatically going to calibrate gold, but we're going to set this thing to calibrate, verify 999 silver. So once it says place sample, I place the coin on it. There are two brackets, one right here, one right there. So as long as it's within the brackets, you're good. Now, I have another one. This is also a silver eagle, but it's in a case. It's outside of the brackets. It's because it's slightly away. It's within the brackets. Okay. Now a case, since it removes the coin ever so slightly, you'll notice how it moved. You notice how it moves when you move the thing away from the actual sensor. It starts to go out that direction towards the right. It even turns into an arrow or something. I know that doesn't look like an arrow, but there actually is an arrow there if you zoom in. Yeah, see, you can see it now, just barely. Well, come on, zoom out. Okay. Well, damn this camera. Press one button and it does something else. Okay. Well, when you have a coin that's in a holder, there's a gap of air, it's ever so slight, plus the plastic. The plastic doesn't really have a magnetic interference. It's just a distance between the sensor and the coin. It causes some minor issues. So every coin, if it's counterfeit, it's got set magnetic properties. The weight should be set, and so should the dimensions. Unless we're talking about varieties of coins. Money, back in the old days, you know, back when this was actual money, not just 50 cents. Ben Franklin $50, made of 90% silver. That silver or gold weight, here's a gold one, had a certain amount of dollar value. And so you really couldn't fool around with how much precious metals content there was, because that precious metals content really was the actual money itself, not the declared value. The stuff it was made out of was the money. So because of that, you really shouldn't see much variation in the actual content of older coins unless you're talking about extremely rare, I don't know, patterns or trial strikes or something. Like some people out there, back when Napoleon was around, a lot of people don't know this, Napoleon owned a spoon made of aluminum. It was worth more than gold at the time. Aluminum was very difficult to work with until the Industrial Revolution came along. So let's take the Sigma Metalytics, set it to pre-1960. Now I'm going to put this $50 on the main sensor. It's within the brackets. Okay, I know that's a little bit hard to see, but it's to the left, but it's still within the brackets. Now what I was getting at is, they made gold coins out of aluminum very briefly, like as a trial strike here in America. They're all worth, I believe, tens of thousands of dollars, even though they have no gold in them. It's because they're so damn rare. I kind of want one. If I could really find one, that'd be cool. Aluminum coin. Imagine a piece of aluminum being worth as much as a piece of gold. Holy crap. Anyway, but point is, since they had a set weight and value, there shouldn't really be any variation. So that means that whatever the magnetic properties are of a coin, and the weight and the dimensions, along with the specific gravity, which is the ratio of the mass to the volume, and then the speed at which sound travels through the object, through the metal, that means all of that should be fairly fixed with very minimal margin for error, unless it's on the part of either the tool or the person who made the actual object in question, or the metal or the coin. So this coin came up real. Here's a Morgan dollar. Now it's got steel staples, but let's see what happens. Ooh, oh, that's 1960, sorry. 1945, 1900. Okay, can you see that? I had to roll it back a few. Run. Place sample. Okay, it's slightly to the left, but maybe the steel has an interference, and that's where you can take one of these wands, if you go to Sigma Metalytics, plug it in, lit up, run cal. Start. Place sample. Okay, it also came up at the exact same spot. Let's take it like that. It's the exact same spot. It's real. Okay. Now, let's have some fun. I do believe that a large gold coin, okay, a gold alloy. Hold on a moment. Let me see what. It should be able to be verified with balanced copper. Start. Should be able to be verified with a large sensor. It's within the brackets. Yeah. Flipping it over. Oh, it's perfectly on the dot. Okay. So it is 90% gold. Okay. Good stuff. Now, if you buy a coin and it fails all of these or any of these, that's reason to suspect it. As in these three, first of all, and these are important as well. However, you can see some variation, especially with details. A lot of counterfeiters, they go after heavily worn coins because it's harder to spot the differences than, say, the details on one of these. This is a Texas silver half dollar from 1937. I've already checked the weight, so I'm not going to use the scale on it. But check the details and everything. I've already checked it with the Sigma Metalytics. I believe it's real. And unless you're a professional grader, you can never be 100% sure, but you can be pretty damn sure. But I want to give people one warning here before I'm done. Silver is a highly conductive metal electrically. So is copper. And we replace silver coins with copper coins. So I showed you that the Morgan dollar came up within the brackets but to the left. This is a clad Eisenhower dollar. I've already weighed it. It does not weigh what a 40% silver proof would weigh. It's within the brackets, and not only is this coin within the brackets, it's actually one notch to the right further than the Morgan dollar was, and I can tell you why. This coin rings up at all as silver. It's not actually ringing up as silver. This thing checks the magnetic properties. I'm going to make another video about that in just a moment. I'll probably run them together. But since this is made of copper, it has extremely similar electrical characteristics as silver does.